hypochlorous acid, phosphorus acid, hypochlorite ion, phosphite ion, sulfite ion, nitrite ion. These are all weak bases. And as salts, they actually change the pH of solution. So we're going to talk about that. Talk a little bit how to deal with polychromic acids. It sounds pretty complicated, but we take an approach that simplifies things quite a bit. And Lewis and acid bases, I'm not quite sure I'll get to today, but we'll try. And it's just another broader scope of way of defining acids and bases. Okay, so that's what's on the agenda for today. Again, just to emphasize, to strategize, you have to figure out what kind of solution you have. Okay, given a solution involving acids and bases, look at it, what do you have? What's, acid, bases, are they strong, weak? When you have basically, a strong acid with strong base, very simple problem, you just do stoichiometry with moles. Okay, moles being molarity times liters concentration, liters of solution. So you do stoichiometry only if you have strong acid, strong base. Like HCl, the sodium hydroxide, goes to sodium chloride in water. Okay. Questions so far? Okay, if not, okay, next, weak acid, weak base. If you have a weak acid or a weak base in solution, okay, those are going to be equilibrium. When you do equilibrium, if it's a weak acid, Ka, weak base, Kb. And you do that basically with an ice table. And when you do the set up the ice table, first thing on top, what do you have? You have the equilibrium reaction. So you need to be able to identify the equilibrium reaction when you have a weak acid in water, what are the products? When you have a weak base in water, what are the products? Very easy to determine. It's always this transfer base plus going from the acid to the base. Okay? So that's how you deal with that. The more involved situation when you have something strong reacting with something weak. Okay? And then there's a couple different scenarios here, but regardless of what's going on, the first thing you do, because you have something strong as a reactant, you need to do stoichiometry with the moles. Okay? Moles of acid, moles of base, and then you have to look at what you have after that. Two scenarios. Okay? It kind of depends what you have as excess. And what is your limiting reactant? If your strong reactant is limiting, you're going to end up with basically no strong acid or base in solution. In other words, you have excess weak acid or base. And I did a couple problems like that before. You're going to end up, and I'll do one today, you're going to end up with a weak acid and a conjugate base. And whenever you have weak acid, conjugate base, you do a second calculation. And that's what we call it, because it's a buffer solution, you use the Henderson-Hesselbach equation. Or you can set up the ice table again and use this double small x approximation. Mathematically, you end up doing the same thing, and you get the same answer. Okay? So one scenario is that all your strong acid or base gets reacted because it's limiting, and you end up with weak acid and conjugate base. And you have to follow up that calculation with an equilibrium concentrate calculation to determine, kind of fine-tune where your concentrations are after you've done the stoichiometry. Okay? And we've done some problems like that, and you can do either the Henderson-Hesselbach equation or the ice table as equilibrium. Keep in mind you have both weak acid on one side and conjugate base on the other as your initial concentrations after the stoichiometry reaction. Okay, now the other scenario is that your limiting reactant was the weak reactant, or the weak acid, or the weak base, and you have excess strong acid or strong base left over. Well, in that case, if you're trying to determine pH, for example, or final concentrations, just realize, well, you have excess amounts of hydronium ion or hydroxide. You can get from pH directly from there. There's no secondary type calculation to do because there's no other equilibrium effectively taking place. You have just the strong acid or strong base in solution and no further reactions are taking place. Okay? So that's kind of like an overall map. of how to consider different types of acid-base reactions. Again, you have to identify, look at what you have in solution. Forget the spectator ions, you get rid of those, it's just going to confuse you. Work with the anions or the cations, whatever's taking place here, and identify among these categories. Okay? Okay, so let's try practice some problems with bases now.